Today we will talk about architecture and which are our biggest architectural problems in our web applications usually, but not only in our web applications, and how to listen to agile practices and agile techniques in order to find a better way to architect our software. We will talk about three essential problems that can be found in most applications. First, your architecture is hard to understand. When you look at your architecture, you don't know what the application is doing. Then it is impossible to test programmatically or automatically. And third, it is difficult to change your code or your architecture because it is prone to human errors and a lot of bugs. I have some good news. There are some answers to these problems. There are several high-level architectural designs you can apply. There are, if you listen to your tests, they will help you find those architectures that will best work for your application. And if you embrace agile practices and apply them to your architecture, it will morph into something that will be useful for your project. How will this help you? It will help you to decouple your business logic from the tools and the external modules you are using. It will help you make your code easily testable, and it will make you test it a lot automatically. It will encourage you to safely change it without introducing new bugs with every new feature. Before we go on, let me present myself. My name is Patkos Csaba. I work for a company called Syneto. Our product is a storage device. You know in the movies when you see those big data centers with a lot of servers inside. Some of those may be ours. Those storage devices are running an operating system, and that operating system needs a management software. Both the operating system and the management software is what we do in our software department. Today I will talk about our experiences in changing our architecture in the past 5 years since we adapted agile techniques, and help you understand that we started with the same problems everybody started with, but we managed to change into something that is more decoupled, that is easy to develop, and that has less bugs than you could imagine. Is this your architecture? How many of you think about this when somebody asks you, what is your architecture? Have you ever seen somebody or heard somebody talking you like, my architecture is Hibernate, Spring, with a little velocity and struts templates. Cool, but what is your application doing? I have no idea. This is not an architecture. This is something like an architecture. What do we have here? We have a storage and a network module, some file system disks, some file sharing, and video streaming through the network. What kind of device could have an application, an architecture like this? Any ideas?
YouTube.
Sorry?
YouTube.
Maybe. Or maybe it may be a simple storage device. Or your media center, your Apple TV, may have something like this. It has a disk, shares file streaming to your TV. Or maybe your homemade Raspberry Pi project may have an architecture like this. The important thing is that you see what is happening inside that application you don't know much about. So this is irrelevant. I don't know if you are building a church, a skyscraper, or a home. These are just tools and bricks. And you may think, okay, maybe I show you some walls. These are irrelevant also. As the keynote speaker said, it is irrelevant if you have a team of 3 or 30. It is irrelevant if you use PHP or Java. It is irrelevant if your building is built from big bricks or concrete. I don't care. What I care about is this. This is the architecture. The buildings, the pavement, the fountain. This is what tells us what is happening in that square. You have an opera house, you have a hotel. You have people in a square. That is what tells you what the architecture is. Or this. If you show you this picture, you will know it is a theater or an opera house. You won't confuse this with the NIST Business Center, right? If you show you only a wall or a window, you have no idea what kind of building is this. So to make an analogy, you can do this type of architecting or presenting your architecture of your existing application. But what if you don't have an application yet? You are just starting. Then your architecture should be your blueprint. A blueprint is never talking about the components of a building. It is talking about the uses of different areas in the building. For example, this is a stage, right? There may be ticketing services. By the way, this is the blueprint of the London Opera House. It doesn't say if the Opera House is built from steel or bricks. It doesn't matter. But it says how it will work, which leads us to this image. Who can recognize this? I've seen a few hands. It is a summarized version of Robert C. Martin's clean architecture. He is basically the inventor or starter of the Agile movement and the Agile craftsmanship movement. And throughout his books, especially in Agile Principles, Patterns, and Practices, the first and the third book, he talks about this architecture. He presents it in pieces so you can build your application and learn how to go from something that is very difficult to understand into something that is clean and easy to test and apply Agile practices. But this is so theoretical. So let's see what is on this architecture. On the left side, we have the delivery mechanisms, the ways your application is talking to the user, and the user talking back to the application. This may be delivered through network, delivered to your console, or your MVC framework. Your MVC web framework is just a presentation framework. And this is very important in what we are about to talk. Then at the bottom, you have the persistence layer, which can be databases, file systems, or non-volatile memory on hardware, whatever. Whatever is your project doing. And on the right side, you have the entry points to the application, index PHP, for example, if you are delivering a PHP application over web, or the main method of your Java or C++ or C application. And your factories are not part of your business logic. They are just creating objects. They are creating the business logic and entering into the logic by doing so. But how do you end up with something like this? We saw first saw this architecture about 5 or 4 years ago, and it was very intriguing for us. However, our current application was nothing like that. And what we are about to talk in the next few minutes is how we took step-by-step Agile practices and ended up in that architecture. Because we started with something like this. We had huge models. The models had business logic classes, data classes, they were communicating with databases, file systems, even sending data through the network other than to the views. And they were creating all the objects, of course, right? And our views, they were no less sophisticated. They even had UI logic, templating, HTML, JavaScript, and they were using directly domain or business objects. Which seems okay at first, but after a few years of creating a big project like a storage device, you realize that is something very bad to do. At least our controllers were decent. They were doing some routing, they had some logic, but only for presentation. Let's just assume they were okay. Then we discovered testing. And we said, okay, this is so cool, I can write a program to test another program. It will be automatic. It will execute the same thing again and again and again. And no more manual testing, no more errors in testing, and so on. However, we immediately realized that it is very, very difficult to do something like that with a model like this. Because you have to exercise the whole MVC framework just to run a simple test on a method. Did anybody here try to test a Rails application? Did anybody tested a Rails application without running Rails? If you didn't, you have a problem. Just to starting up Rails takes like 2 seconds. If you have 1,000 tests, that's 2,000 seconds just starting up Rails without actually testing your code. So that is very difficult. And it leads to slow tests that are hard to maintain because half of your tests will be framework initialization and somewhere in the middle you will have a few lines of actual code tested. And the headache to maintain something like that, it doesn't worth the effort. So we ditched our models. We took all the mess out of the models. We kept in the models only API calls to the business logic. And if your framework favors validation in the model instead of the controller, that should remain there. However, in most MVC frameworks, you can just ditch your models altogether and forget about them. Just use the controllers and views. Our framework, the framework we are using, prefers validation in the model, so we kept them. That helped a little bit. At least we could exercise a bunch of messy code without exercising the MVC framework as well. It was a little bit faster, but there were a lot of problems. First of all, the code was the same mess. It had the same problems of dependency. It had the same problems of communicating to databases, file systems, and network. It had the same problem of crossing so many layers of abstraction. And the tests kept to be ugly. And crossing the boundaries made them very error-prone. You may change the MySQL version, and your test may fail. Should your business logic test fail if you change MySQL version? No. You should have some tests to verify that you can talk to MySQL, but your business logic tests should remain unchanged. Then we started to discover the Agile principles, the solid principles. Who knows them? Okay, that's cool. So there are 5 principles, and we started to listening to them. From those 5, we will talk about 3 today. I consider the remaining 2 only additional to these ones. The single responsibility principle. This was probably the biggest and most important one for us. It had a huge effect on how we organize our code. And this is probably the most difficult to understand principle from the 5. It is very philosophical. It says that everything should have a single responsibility. Your module should have a single responsibility. Your class should have a single responsibility. What is a responsibility? People first think, okay, responsibility is that my module should do only one thing and nothing else. Wrong. A responsibility is a reason to change. Writing to a persistence may be a responsibility for the persistence module. That module should not change if the accounting department needs a new tax. That is another reason of change. That module should only change if something changes related to persistence, for example, from the database architecture department. And when you understand these actors, and that responsibility means reason to change, you start to see these modules popping up of your architecture. The most obvious ones are these extracted here. This is something you can apply to most applications. Your database, file system, factory, network communication, these are all responsibilities very well defined. You will find others specific to your business and specific to your project inside your business logic, but I can't go there right now. So, out of the factories, and the code remains simpler with only business logic inside. But how do you connect all these together? Next, we thought about the open-closed principle. This basically says that your code should be open to extension and close to modification. You always prefer to extend what it is for a new feature instead of modifying something that already has been written. Which helped us a lot to take out the code and transform the original place into just some kind of entry points like a mini API. Have our business logic here, like a plugin to the API. And still, our business logic depended on databases, file system, factories, and so on. The flow of control and the flow of dependency was from the business logic towards these external tools. Which leads us to the dependency inversion principle. This is something really cool. I personally, this is my favorite. It is like reinventing plug and play. You keep the control of the execution from the business logic towards the external tools, but you don't care about them anymore. They are just plug and play pieces to your business logic. That means that a database depends on your business logic. Your MVC framework that is for presentation depends on the business logic. The business logic doesn't know about them. That means that your business logic doesn't know about how your information is delivered to the user through the network, through a physical console. It doesn't matter anymore. Which leads us back to this architecture. And the coolest part is that you can test these. All the external tools can be tested in isolation without touching the business logic. I can make sure that these modules are behaving as I want them to behave. Then I can test my business logic in isolation without caring about the modules, because I don't have to know how classes are created in order to use them, to test them. I just test them, I create the instances in my tests, and I let the factories to be tested separately. And finally, it lets us test the boundaries that are connecting all these pieces together in isolation again. A test here will never create a real business logic object or a real factory. It will just test the communication between these two. Same goes here. And how do you implement this? It's easier than you think. Try out design patterns and try to think about this schema and design patterns. Crossing the boundaries here, proxy, gateway, or from domain-driven design, the repository pattern. Crossing the boundaries here, facades, maybe various API design patterns. Crossing the boundaries here, it is a factory, already a design pattern, right? So all around here, you can find design patterns. You can implement very easily a communication boundary with observer and visitor. And when you realize that all these are just pieces of design patterns everybody in your team can understand or can learn to understand in time, then architectures like these will become very easy to grasp. Who did ever take a look at AngularJS's code? It is like written on design patterns. When I looked at it first, it was like, okay, here is a factory, here is an observer, here is a visitor, these are connected this way, this should happen. I understood very quickly what should happen there. And that was awesome. And you can do that in your own application. Which means that you can have like almost 7,000 assertions run in less than 2 minutes. These are our actual unit tests. And besides these, we have some integration tests, which are verifying communication between modules, some tests for those boundaries when we are actually exercising several external communications, and a few end-to-end tests. But let's say those are not so relevant that these 7,000. So if I write code, I usually just run the test for the module I was working on. I hit commit, push, and in 2 minutes I am getting an email like this. If something goes wrong, my phone will ring on Hangouts. I will have a pop-up in my IDE that something went wrong, which is the test that failed, and how it failed. Because when you write so many unit tests, you have a huge advantage. You are testing very small pieces of code, and your tests are very easy to understand. When this fails, I will understand exactly what failed, in what method, in what class, at what line. Compare that to an end-to-end test, or something that even exercises your MVC framework, and you will have something like MVC framework Spring says it couldn't inject some dependency, module 11, and you have a stack trace that is 3 screens long, and you have to find there what is the problem. Most of the time you will not be able to. However, if this test fails, it will tell me exactly where the problem is. And maybe I just tell you what is this test? 4 lines of code only. That it tests that a disk, a physical hard disk, can be blinked. Each hard disk has a small LED on it. We will use the external tool called whichDisk, which will never be created for real. It is just a mock. Then we will create a real disk object from our business logic, the thing that we are testing, and we will verify that when we call the start blinking on our disk, our external module will receive the identify call with the disk name specified for our business object. And that is 4 lines of code. As I explained it to you, I can explain it to any of my colleagues, and they will understand it, and they will remember it and re-understand it next time. Many of these will help you a lot. Let's do a short recap. Given you want to test your code, when you realize you are limited by the frameworks, then isolate your business logic from the other tools. Given you want a clean architecture, because you decided in the first step, right? When you don't know how to get there, listen to tests and listen to Agile practices. They will help you a lot. And finally, given your code is hard to understand and test, when you get a clean architecture, you will have much less fear of change, both of the code and the architecture. Thank you, Dan. If you have any further questions, I will be around all day.